Alright, recording. Here is the second SSE video, Seeing Structure with Expressions. I'm tired of saying the disclaimer, the whole thing, so just remember this list and video series is not all inclusive of all the stuff you need to study. Okay, for these two we have to fully factor and sketch. You have to be able to recognize all the structure and all the different ways there are to factor, all the different identities to use. When you're thinking about that, also think about this, and I've said it before, I'll say it again on these videos. The first thing you should look for anytime you're going to try to factor or solve is always look for a GCF first. It makes your life so much easier. What's the GCF of these three terms? It's x. As a matter of fact, if you don't factor out that x, this is an impossible problem. So we get x fourth minus 29x squared plus 100. Now you have to realize, okay, this is a quadratic pattern. It's going to factor just like the magic x, except the first two terms are going to have x squared and not just a single x. So we can just basically do it the same way. What adds up to negative 29 but multiplies to 100? In this case, it's minus 25 and minus 4. So there's our binomials. Let's see, we have an x outside, x minus 25, x squared minus 25, and this one is x squared minus 4. Are we done factoring? Say no. Do you recognize what the structure is right here? Difference of squares. So this one becomes plus 5 minus 5, and this one becomes x plus 2x minus 2. So we have it fully factored. Now we need to sketch it. Let's see, where's the y-intercept? It's right there at that 0. We have that one, and then 3, 4, 5. 1, 2. You guys see there's zeros at plus or minus 5, plus or minus 2, and at 0. Maybe some of you might remember, is this function even or odd? This function is odd because all the exponents are odd and there's no constants. So this is actually symmetric about the origin. So what's the end behavior of this function? Isn't it down up? Because of x to the fifth? So it's going to kind of go like this. Done. Pretty cool, huh? That's actually a pretty good sketch. It's the best freehand one I've done. Okay, over to the second thing to fully factor and sketch. This is a difference of cubes. Best thing you can do is to memorize the identity for factoring a difference of cubes. Let me give you the recipe. You guys are going to recognize this once I show it to you. Once you find the cube root of the two terms and keep the sign, remember it equals that. Now, what do I multiply for the trinomial here? It's always the same. A squared, change the sign, multiply the two terms together, and then square the last term. It's always the same. Whatever it's plus or minus, you use the same recipe. So what's the cube root of x cubed? X. And what's the cube root of 27? 3. Now, what's the next part? We take the first term squared. That's x squared. We change the sign. What's the two terms multiplied together? Isn't that 3x? And then the last term squared. Done. Now the bad news is I want you to sketch this as well. What's the 0 from this factor? 3. What's the y-intercept? Negative 27. So we're going to say that's right there. What's the end behavior? Isn't this down up? Okay. And you would have to figure out from that trinomial that's left over if it has two real roots using the quadratic formula or if it has two imaginary roots. Do you remember what little tool I taught you guys to figure that out? It started with a D, rhymes with discriminant. The discriminant, b squared minus 4ac. Do you guys remember this? See if this value is negative. If this value is negative, that means you have two imaginary roots. So it's b squared, that's 9. Minus 4 times a times c. So that's 9 minus 36, which is negative 27. So this trinomial is going to have two imaginary roots. So you only have one root at 3. We got this end behavior and two imaginary roots. I don't know where the imaginary roots are, but we're just going to draw it like this. There you go. There's your two imaginary roots, and there's your one real root. That's how you sketch it. Any questions? Chris?
Can you also say one pair of imaginary roots?
You can. Any other questions? All right, good.